Okay, so we were talking about Toshi's special sauce, which maybe has something to do with these stack traces. I'm not sure yet. The idea is you insert some monitors into the application's binary that give you a little visibility into those other interfaces. So what do you want to instrument in that way? Sources of input and potential sinks. So places where vulnerabilities might occur. Places where you execute database queries, places where you access the file system, places where you execute commands, access the file system, sorry about that. And you look for problems. This helps with that oracle issue that we talked about before. So how can you identify when a vulnerability has actually occurred? Some of the benefits are you get the ability to measure how much of the interesting APIs have you actually covered. So if Toshi runs this tool, runs his black box test, and sees a coverage number of 1%, he knows he's probably not getting a full picture of the bugs in the application. If he gets it up to 70, then in 45 minutes, he's probably not going to try to max it out much more. He also gets some code level details. So as opposed to a vulnerable URL, now he actually knows the line of code where the vulnerability might actually exist. And as I said before, you get access to improved oracles. So you can tell vulnerabilities where data is written out to the file system or another external interface. So this animation, which you can tell I'm not exactly an artist, illustrates the difference between the two approaches. So traditional black box testing, you throw some input at the application, and you watch the response coming back and try to make a decision based on that response. Now, this is the exciting part. Hold on. Toshi's approach, you insert monitors into the application. Input comes in the same way, but now you can tell everywhere that it goes. So you monitor all these other APIs throughout the application, and you get a lot more visibility into potentially what's going wrong. And we'll see some examples of this on his screen later on. So how do you go about inserting these monitors? Obviously, you could write them into the source code when you're developing the application, but that kind of defeats the purpose since you're probably not the one developing the application. In this case, they're written as aspects, and we're going to use aspect-oriented programming to modify the bytecode and insert them just before you deploy the application. The biggest advantage of this is that you don't need any source code. So we've given the code to these guys so they can investigate it as they want to, but their tools actually aren't going to leverage it. The idea in the Java case is you've got a class file, you've got some monitors written as aspects, you pass them through aspect-j, out comes a new class file with the monitors added on. If you imagine you've got this getStuff method, the interesting query here is, the interesting method call here is execute query. So we're worried about potential SQL injection. We've got an aspect that says every time you see an execute query call, insert a monitor that checks the query string for various patterns. And out the other end comes a class file that represents the code on the right. So to summarize, Toshi's black box tool is really a smart fuzzer. So it's using, just like the other vendors in this space, it's using known attack strings, things that are designed to exploit certain kinds of vulnerabilities, to fuzz the application, look for vulnerabilities using a couple of techniques, signatures and behavioral analysis. His white box tool is injecting monitors and looking for potential limitations based on how much of the application he's covered, getting code level, API level details, and getting more enhanced oracles for different APIs, different kinds of vulnerabilities. What's going on Sean's screen now?
It looks like he's still cranking through results. He's in the HTTP response splitting class and stepping through traces through the code.
And it looks like he might have forgotten what HTTP response splitting is because he's got the description for the vulnerability category up too. Sean, is that helping you out?
Jacob, what do you say we go back to talking about some more interview questions?
What have you got next, Brian?
What's your favorite type of security vulnerability?
Toshi likes command injection because the next step after that is usually owning the box.
Sean says there are a lot of good ones out there, but it's hard to beat buffer overflow because it's got a certain timelessness to it, and it's a classic that never goes out of stock.
The next one is a little deeper. Do you have any advice for people who want to get the most out of their tools?
Sean says customize. You can find a lot of good problems out of the box with static analysis, but every application is different, and you can usually get a lot more out of a tool if you write your own rules.
That answer gets an F because it must have been cheating. Toshi says customization goes a long way.
You know what I think it is? I think these are two guys who work a lot on tools, and they appreciate smart, engaged users.
How about users who do some of the work for them? I think that's pretty good, too.
Next question. Do you have any advice for people who want to create their own tools?
Toshi's got a two-part answer. First off, he says, I hope you don't have a social life, because it takes a lot of work. Secondly, he says, seriously, it's easy to make a tool that kinda works. The hard part is making it work all the time.
Sean says that you should try and build on what's already out there. First, identify what you want your static analysis tool to find, and then see if there's a framework that you can build on top of to do that. There are a lot of good open source static analysis platforms out there, and if you can avoid building something from the ground up, you'll save yourself a lot of time.
Kind of on the inverse, do you have any advice for people who want to create their own tools? Did we do that one already?
Yeah, that was one we just did.
Sorry about that. What's the most important thing you do in your job?
Sean says sitting down with users.
Toshi is obviously cut out for management. He says prioritization and guidance for his team.
The next question, how did you get interested in security?
Toshi's got a good one for this. It's kind of nostalgic, actually. In college, we used to use Unix write and talk commands to talk to each other. Then I realized if I dump a core file to the write command, then the other user's terminal is essentially flooded with junk. I thought that was pretty cool.
Sean says he's not interested in security. He's just in it for the ladies.
Next one, where did you grow up?
Sean's from Ipswich, Massachusetts.
And Toshi's from Japan.
Oh, I like this next one. Why do you think you're going to win the competition today? Sean says, because if the tool falls apart on this code, Jeff Morrison has a static analyzer in his brain.
Toshi's taking a politically sensitive approach to this one, and I hope this doesn't get him in trouble today. 2 runtime tools companies just got acquired recently, and he says, would you want to bet against HP and IBM?
Next question. What other software tools do you take inspiration from? Sean says he likes tools that make developers' lives easier. IntelliJ is the one in particular that he called out. He's also learned a lot from looking at other static analysis tools like FindBugs.
Toshi didn't answer this question, so I'm going to fill in my analysis for what I think his response means, which is that he's only inspired by his own tools. He doesn't like anybody else's. So what's going to be the next big thing in security?
Sean says he thinks that it's going to be runtime tools like the ones that Toshi is using.
Well, that was a friendly answer. That must have been for copying the other
I
one.
hope that's not an olive branch of some sort.
So Toshi's response is somewhat diplomatic as well, which is he thinks static analysis and runtime analysis tools will start to play more with each other and feed output from one into the other and gain some benefit from that hybrid approach.
Okay, let's get right down to the point. Next question. Are false positives a problem? And if so, what do you do about them? Shall I go first for Sean? Sean says definitely false positives are a problem for static analysis, because false positives make life harder for the user of the tool. But they're a fact of life, and the strategy is to minimize false positives where possible, but to make it easier for users to understand results so they can figure out whether they apply in their environment.
Toshi says false positives aren't a problem. I think he qualifies that with, there are a few false positives, but false negatives are a much bigger issue. So he spends most of his time trying to reduce those. All right, Brian, what's going on over here? Oh, that's a good one.
Why? Why did you jump on that one?
I saw a big red X on the screen on an error message. I couldn't tell what it said, though. Did anybody catch that? That's not very exciting.
Well, that's helpful. I guess that's what you mean by helping the user, Sean?
I'm going to peek in over Eddie's shoulder since we can't project his screen. He's got the application up. Oh, it is. What's on Toshi's screen, then? So Eddie's got 5 cross-site scripting vulnerabilities on the screen. That sounds pretty exciting. And Toshi's still playing around with the app. Are you setting up a wiki?
That'd be a good way to present your results, I think.
Yeah, that's much better than PowerPoint. We should think about that. Extra points, I think.
Okay, next question. How do you prepare for the competition today?
True to Las Vegas style, and I think Iron Chef as well, Toshi tried to make reservations at Nobu, didn't get one, so he's feeling a little underprepared.
Sean went with a food-related preparation regimen, too. Meditation and a strict diet of lentils and rice milk.
And beer. So, if this were the original Iron Chef, what would you cook?
Sean says peanut butter and jelly because he's not a very good cook.
Oh, Toshi went the other way. Butter poached lobster, but he's eating them all himself. No sharing with the audience.
Okay, Jacob, you want to set me up and we'll take a look at static analysis?
Sorry, Sean.
All right. So, you may be familiar with static analysis tools that started coming out around 10 years ago. I'm talking about tools like ITS4 and Flaw Finder and RATS. Let me tell you, these tools are essentially prehistoric. Sorry, John. John's one of the authors of RATS. Oh, and it's 4. Hey, I didn't mean to cut you out. Okay.
So if Sean loses the static analysis vote from John, you know why.
So here's what these tools were good for, though. These tools basically were a fancy kind of grep. They were a good way to collect a body of knowledge about what could go wrong and then apply that knowledge to a big body of code. That's great for security experts who need to go through and do a code audit. It's also really good because you've got a repository for your set of bad coding practices. The thing that was bad about these tools is when people who wrote software or who weren't security experts got a hold of them, they figured out, oh, wait. This isn't a bug finder. This is like some sort of code audit tool. Essentially, these tools weren't incredibly helpful to people who didn't have a lot of security expertise already. So, now I'm going to tell you about what probably the number one thing that the new generation of static analysis tools do that differentiates them from the old bunch.
Sorry to interrupt here, Brian. We're up to 13 cross-site scripting bugs on this side. Eddie's making progress.
Cross-site scripting vulnerabilities in a wiki? What?
No, I don't believe it.
Okay, so the advanced static analysis tools do a much better job of prioritization. And the code that I put up here illustrates that point. It's got 2 calls to stir copy in it. So when should you be calling stir copy? You shouldn't be calling stir copy, right? So it's very, very reasonable for one of those old tools to call out both of those calls to stir copy and say, I don't like either one of these. These 2 are not equivalent, though. One of them is much, much worse than the other because one of them just copies over a static fixed-size string into a fixed-size buffer. The other one takes user input and tries to jam it into that fixed-size buffer. One of them is exploitable, and the other one isn't. So it makes a lot of sense for the siren to go off when you see that second call to stir copy. And that first call to stir copy ought to be like, you really shouldn't do this, but you're probably not going to get burned on it today. So prioritization is probably the number one thing the new security tools do. So let me give you a pitch for why static analysis is good for security. You know, people use static analysis for all kinds of stuff. They use it for, when you do type checking, when you compile your code, that's static analysis. But let me tell you why it's particularly good for security. It's really fast compared to manually reviewing the code. Has anybody gone down that route? Anybody take the code? Hey, I think we got at more than 15 minutes yet. Boy, would you be a Jedi Master if you started bug hunting now. Come on up and get some code, though, if you want to.
How many people do we have looking for bugs right now? Wow.
I see a couple hands, but I bet a couple more people are like too lost in the code to raise their hand.
No one's listening to me.
Okay. Doing static analysis is fast compared to testing. Because when you do testing, you've got to actually put the software in all of the different states that you want to look at. Static analysis can sweep through the code and treat it all